All right. So starting this chapter 3 review, I'm going to split this video up into a few different videos, or this key up into a few different videos. Let's just start with graphing. So graph each function, plot two nice points in the asymptote, fill in the information for each function. So to begin with, this is a 3 to the x parent function. So you need to know what the two nice points are. So for exponentials, when you plug in 0, you get 1. When you plug in 1, you get the base number, which is 3. And they begin with a horizontal asymptote, y equals 0. And then what has happened to this function? So remember, stretch and reflect first. So we're going to figure out x to y because of the 2 out in front. So that's going to change this to 0, 2. And 1, 6. Y will still equal 0. And then you're going to go left 4, and because of the plus 4, and down 1. And when we move down 1, that will affect, the horizontal asymptote as well. So from y equals 0, it goes down to y equals negative 1. And then the point 0, 2 goes left 4, 1, 2, 3, 4, and down 1. And then the point that's at 1, 6, 1, 6 goes left 1, 2, 3, 4, and down 1. And then we sketch this curve in. All right, so filling in the information. Some of this we can get from the work we've already done. The asymptote equation is y equals negative 1. Make sure you put in y equals if it's horizontal and x equals if it's vertical. The domain here for an exponential function is all real numbers. The range I can see in my graph is negative 1 to infinity. And then you guys don't have both x and y intercept. I think you only have y intercept. So let me do that one first. You should practice doing both, though. I could ask either or both on the test. So y-intercept is when you plug in 0 for x. So remember, y-intercept is like 0, y, and x-intercept is like x, 0. So for the y-intercept, that would just be, look at the equation again, 2 times 3 to the 0 plus 4 minus 1. So 3 to the 4th is 81. So this is 2 times 81 minus 1. 2 times 81 is 162. 162 minus 1 is 161. So we're definitely not going to graph that, but that is where the y-intercept is. And then the x-intercept is when y is 0. So you're setting this equation equal to 0. So 2 times 3 to the x plus 4 minus 1. So this is just an exponential equation to solve. Now that we've done this with equations, we can apply it to our graph. So I would add 1, divide by 2. So now it's 1/2 equals 3 to the x plus 4. I would log base 3 both sides and subtract 4. You can put the minus 4 at the end. I just put it out in front. So whatever that is the x-intercept. Okay, let's look at the second graph. This one is a log graph. The parent function is y equals log base 2 of x. So what are the nice points there? Remember, you kind of flip these. It's 1, 0. And someone said they remember that because that looks like log, right? So if that helps you remember, 1, 0. And then the base number 2, and you put in 1 for y. So again, you're just kind of flipping the exponential. Instead of y equals 0, it has a vertical asymptote, x equals 0. And then what's happening to this graph? So we have two adjustments to make before we get started. There is a negative in front of the x and a horizontal shift. So factor that negative out. It's still in the parentheses, but factor it out of these two terms. That would make this positive x, and this 4 would become minus 4. All right, so there are two negatives in here. So that means we need to make both x and y negative. So let's do that. Negative 1, 0, negative 2, negative 1. This would still be x equals 0. But then the shift is to the right 4 and up 3. So shifting a vertical asymptote from 0 to the right 4 is going to put the vertical asymptote over here at x equals 4. And then I've already reflected my points, and I'm just shifting them. So negative 1, 0 goes right 1, 2, 3, 4, and up 1, 2, 3. Negative 2, negative 1 goes right 1, 2, 3, 4, and up 1, 2, 3. So I'm just going to sketch something like this. Okay, and then filling in the rest of the information. So the asymptote equation is x equals 4. The domain, I'm just getting this from the graph, is negative infinity to 4. The range is all real numbers. Okay, and then again, you probably have, let's see, x-intercept on this one and not the y-intercept, but we're going to do both. So for the x-intercept, that's when y is 0. So set the equation equal to 0. And now that we've solved log equations, you guys seem to be pretty good at the log equations. So how do we solve this? So we want to get the log on the other side. To get rid of a log base 2, I can base 2 both sides. So now it's 4 minus x equals 2 to the third, which is 8. I would add x over to this side, subtract 4 over to this side. X equals negative 4. And you could even include that in your graph if you want to. That extends the graph beyond there. For the y-intercept, which is the one you don't have, but you probably have space to do this, that's when x is 0. So plug in 0 for x. So you would get y equals negative log base 2 of 4 minus 0 plus 3. Okay, so what is that? That's negative log base 2 of 4 plus 3. Remember, we can evaluate that. Log base 2 of 4 is just 2, right? Because 2 squared is 4. So this is now negative 2 plus 3. So the y-intercept is 1. Does that fall in line with what I have for my graph? Yeah, right there. Okay, last graph. So this original parent function is y equals log base 6 of x. So our two nice points are 1, 0, always, and then the base number is 6, 1. Starts out with a vertical asymptote x equals 0. This one has two dilations going on. So remember, the x values get divided by the number that's in front of x, so x divided by 2, and the y values are always multiplied by the number out in front. So let's do that math. So this becomes 1/2, 0, and 6 divided by 2 becomes 3. 1 times 4 becomes 4. 0 divided by 2 is still x equals 0. And then there's no horizontal shift here. We're only going down 1. So if you shift a vertical line down, it's still sitting at x equals 0. 1/2, 0 needs to go down 1 unit. So you're at 1/2, negative 1. 3, 4 needs to go down 1 unit. So it's right there. And remember, this is a log graph. So if you're having trouble with like the curvature, it's not going to cross through the vertical asymptote. It's going to kind of curve and get closer to the vertical asymptote and gradually extend higher. So the asymptote equation is x equals 0. The domain from the graph is just 0 to infinity. The range is all real numbers. You guys would have the x-intercept on here, but we're going to do both. So the x-intercept, again, is when y is 0. So we set our equation equal to 0. So it's 4 log base 6 of 2x minus 1. It's 1/4 equals log base 6 of 2x. All right, how do we get rid of this? We base 6 both sides. So 6 to the 1/4 is equal to 2x. So whatever, this is 4 through to 6. I don't care how you write it. 4 through to 6 divided by 2 is our x-intercept. What about the y-intercept? So that's when you're plugging in 0 for x. So that should be y equals 4 times the log base 6 of 0 minus 1. We can't do that, so there is no y-intercept for this one, which makes sense because look at the graph. You could also get this from the graph. There's a vertical asymptote at 0, so we can't get that from the graph. All right, I'm going to stop this video here, so this will be just the graphing video.